Hey everybody, here's a quick recap of the Hawaiian Islands activity. So our goal is to figure out how fast these islands move, and we can do that using the satellite image of all the different volcanoes that exist in Hawaii. Every single one of them started right here at the Loahi Seamount, cracking the Pacific Plate. As they form over the course of millions of years, the plate pushes away. And these volcanoes end up over here, with the younger volcanoes over here and the way older ones over here. Looking at this satellite image, it's set up in a way so that 1 centimeter equals 40 miles. That's an important thing to record right here. So if I look at each individual volcano and I'll start right here at the center of the Loahi Seamount. I can measure these. So I can see that this first one travels about 2 centimeters. And it did that in 0.004 million years. I'd want to record that in a data table. And that can be on your Chromebook, and that's a great place to graph this. But what you'd graph is the fact that this thing drifted 80, and this distance is measured in miles, because again, that was 2 centimeters on the image, 1 centimeter is 40 miles, so 80 miles. And it did that in 0.004, and this unit right here is million years. You would do that with every single volcano on here. Use all the data you possibly can. This one right here, way far away, has drifted about 15 centimeters on the satellite map. And 15 centimeters, 15 times 40 is 600 miles, and that one took 5.1 million years. Once you get all of your data all gathered together, you can put that on a Google spreadsheet. Once you make that graph, it kind of looks like this. And what we get is a graph with distance in miles on the y, time in million years, and a trend line. R squared value of 0.948, not like R squared of 1 or 0.999 we'd get when we did the toy car. This is actual data with islands that move in all sorts of different ways. So this is a pretty linear trend for millions of years. The big idea that we have on here is this, the slope. This is a position versus time graph. So the slope equals our velocity or our speed. And so that means we are moving at 100 miles per million years. That's a pretty cool fact to know, but we're not going to live for 1 million years, so we're not going to see that 100 miles of drift. So I often like to convert that into centimeters per year. You can do that if you have 100 miles every million years. Well, what that also means is 100 divided by 1 million is, wait for it, 1 divided by 1, 0, 0, 0, 0, 0, 0. That is a small number. I'm just going to cross out 2 zeros right here. And there we go. It's 1 over 10,000. Miles per year. Well, that's a weird thing, 1/10,000th of a mile. How much is that? So I'm going to convert that from miles into centimeters, and that's 160934 centimeters. Multiply those together, and what you get is 16.1 centimeters per year. And that is how fast the Hawaiian Islands are drifting.